For this video, we are going to talk about polynomials and just a little bit of review about some terms having to do with polynomials and some of the characteristics that you can tell about the graph based on a polynomial equation and vice versa. So first, let's take a look at just the generic way that a polynomial is written out, because it can be kind of confusing if you haven't looked at it before, if your teachers haven't written it out or explained it here before. But all this is doing, so all of these numbers in front of the x's, okay? So all of these are just random numbers, okay? And they can be any number. They can be any real number. They can be decimals, they can be fractions, they can be positive, they can be negative, they can be square roots, any number goes for those coefficients on each of the terms. Then you've got the degree. And the exponents in a polynomial have to be positive whole numbers. Okay, so they have to be positive whole numbers. So you cannot see decimals up here or square roots or fractions or negative numbers. Okay, your exponents all have to be positive. And then this is just standard form, meaning that your highest exponent is going to be first. Okay, so if this one was 8, then this would be 8 minus 1 or 7, and then 6, 5, 4, 3, 2 until you get down to 1 and then none. Okay, now not everyone has to be represented, so you don't have to have 8, 7, 6, 5, 4, 3, 2, 1. You could skip some. So if I just write out an example polynomial here. So if I just do a polynomial, let's say that we have negative 5x to the 6th, and then plus 3x to the 2nd minus 4. So you could have something like this. Okay, so this one has a leading coefficient of negative 5 because the lead coefficient is always the number in front of the highest degree. If they are out of order, then you need to write them in order. So get the highest degree first and then write them in descending order, which you should be used to. So the leading coefficient here is negative 5. The degree is 6. Okay, and then when we talk about terms, so terms are split up by adding or subtracting. So in this case, this polynomial, here's one term, okay, the negative 5x to the 6th, the 3x squared, and the negative 4. So this one here has 3 terms. So if you wanted to name this one would be named a trinomial. There's also binomial that has 2. Okay, so binomial is 2 terms, and then monomial, which is 1 term. So there's a lot of things that we can tell from polynomials based on their leading coefficient and their degree. So mainly the degree. Let's focus on the degree for a second here. So the degree actually tells us quite a bit, and we're going to look at the graphs here in a second. But the degree is actually the same as the number of solutions that this equation could have. So solutions, or really roots, because it's from the graph. But solutions, they're also called roots. They're called zeros. When those are real numbers, they're also called x-intercepts, okay? So they're where the graph crosses the x-axis. But so if you have a 6th degree polynomial, there are 6 numbers that would be solutions to that equation, real or imaginary, okay? But 6, or if it's a quadratic, an x squared, you have 2. They could be the same number, so some of them could have what's called multiplicities. So that is a solution, or a root is a solution a few times, which we'll get into later. But what you need to remember is that this polynomial has n solutions. Okay, there are n solutions to that polynomial. Then some other things to do with the degree. It's a big deal if it's even versus odd. We're going to look at that. It does some different things to the graph depending on if it's even or if it's odd. And the end behavior. So this is going to impact end behavior if it's even or odd. And we're going to get into all of this. And then the lead coefficient impacts the way the branches kind of go on the graph. So let's take a look here at a couple graphs. So for this one, so if we want to talk about, so again, I said we can look at the degree. We'll know about the degree based on this. And we'll also know about the lead coefficient, because the lead coefficient is going to change the direction that these go. So in this case, this is an odd degree polynomial, okay? This is an odd degree polynomial because the end behavior has one branch going up and one branch going down. So both of these are odd. Okay, one is going up, one is going down. And then so I kind of covered up the middle because it doesn't matter what's happening in the middle. It doesn't matter what the degree is. It doesn't matter if it's an x to the first, x to the third, fifth, seventh, x to the 41st. It doesn't matter. The end behavior is going to do the same thing with one branch going up and one branch going down. And if you think about linear, okay, because linear is an x to the first polynomial. So when it was like this, okay, and you talk about a hiker going up the line, so the slope is going positive. If your polynomial looks like that with an arrow down on the left and up on the right, so it's going up overall, this is going to be a lead coefficient that is positive. Okay, so your lead coefficient for this one, your a value, is going to be greater than 0. And if it's going down left to right, so when you read your function left to right, if it's going down left to right, then this a value is going to be less than 0, just like a linear, okay? And then we're going to start describing the end behavior with limits, but for right now, I'm just going to say as x approaches infinity, what is f of x doing? And as x approaches negative infinity, what does f of x do? Okay, and we're going to do this for both of these graphs. So on this one, so as x approaches infinity, so remember infinity for the x's is over here and negative infinity is over here. Okay, so as x approaches infinity, so as x is going to infinity, where is your function at? So where is this function at? Okay, and this function is going up on the right-hand side. So if we could zoom out, this would be way, way, way up off the screen at positive infinity. And as x goes to negative infinity, meaning the left side of our graph, where is the actual equation or the actual line? Okay, so where is your function over here? Well, it's down. Okay, we see this arrow down. So if we could zoom out, we would see this is just way down here at negative infinity for the y values. So then looking at this function, when the lead coefficient is negative, so this would be something like negative 3x to the 5th. Okay, it's just upside down. So this lead coefficient is negative. So let's put on infinity and negative infinity for the x's and think about this. So as x approaches infinity, where's your graph? Well, your actual line is down here. Okay, so at x equals infinity, the graph is way down at negative infinity. As x's go towards negative infinity, where's your graph going? Well, your graph is going up over here. Okay, so going up to positive infinity. So that's called the end behavior. So let's take a look at these ones. So these ones for the degree, so these are even degreed functions. Okay, so the degree in these ones are even. We can tell because they do the same thing. So they both go up or they both go down for the degree, or for the branches, for the end behavior. That will make it an even degreed function. If they're both going up, that means that the lead coefficient is positive, so your a value is greater than 0, so something like 3x squared for something like this. Or if they both go down, then your a value is negative or less than 0. So this could be something like negative 3x to the 4th power or something like that. Okay, so when you're looking at those branches. And so then if we take a look at this, so as x approaches infinity, where is your function going to be at? Okay, and as x approaches negative infinity, again, where's your function at for each of these? So now in this case, with the branches going the same direction, the end behavior is going to be going the same direction as well. So these two answers will be the same within the same problem. So as x approaches infinity, so when your x's are going to infinity, where's your graph at? Well, it's up. Okay, so on the right side of the graph, the branch is pointing up. So the function is going to infinity. On the right side of the graph, so as x's are getting to negative infinity, where's the graph? Up again. And then in this one, as x approaches infinity, what's the graph doing? Well, it's going down because the branch is pointing down. Okay, so negative infinity. As x approaches negative infinity, where's the graph at? Again, down at negative infinity. So if they go in opposite directions, it's an odd degree, and if they go in the same direction, it's an even degree. So let's take a look at a graph here and see what we can tell about it. Okay, so you don't have the function listed here, but you can tell a few things about it. Okay, we can see that we have this side of the function going up, this one going down. So that means it's an odd degree. Okay, so we for sure know the degree is odd. Okay, it's also down on the left and up on the right. Okay, so overall the function is going up, meaning that the lead coefficient, the a value, is bigger than 0. You can also go even further for this and see that it goes up, comes back down, and goes back up. And you see these three solutions here, so it crosses the x-axis 3 times. This actually means that you know the degree is a degree 3 polynomial. So we actually know that it's an x cubed polynomial. For this one, we can see that there's an arrow down and down. So the arrows are down on both sides. So this means that your degree is even. And since they're both down, that means that the lead coefficient here is negative. So less than 0. So something like negative x to the 8th or something like that. And in this case, we actually can tell because it goes up, it turns, comes back down through the x-axis. When it turns again, it goes past it, back down. So we actually see all of these solutions here. So 3, 4, 5, 6 times it crosses. So this is actually a degree 6 polynomial. So this could be negative 7x to the 6th. So we know that it's a negative lead coefficient and it's a degree 6 polynomial. So those are just some things that you can tell on the polynomials. Remembering lead coefficient is just the number out front of the x with that highest degree or highest exponent. Okay, so make sure you write them in standard form. Binomial is 2 terms, monomial is 1 term, trinomial is 3 terms, and then you can kind of analyze the end behavior based on the degree and the lead coefficient.